Hello everybody and welcome back. Today we are going to explain how trains work. So I've made this little map with all the things we're gonna need to explain the trains, starting from the very basics. What can I do with trains? Well, you can connect stations obviously, but that's not what I meant. How do you use trains? First of all, you need the rail. The rail, which you can have in your inventory or your bar, and you pick it up and then you see that it has specific rotations up and down, that left to right and straight and that, and we're back to where we can. So it's not a lot. 1, 2, 3, 4 different ways, but with 4 different ways you can make everything possible in the game. So how do you place them? Well, just press down and move. That's normal way. We know all of this before, that's how we place things. But there are also other ways. If we place one, then we can obviously use the palette sweep, the palette selection, which is move over something that you want and press the Q button, and if you have it in your inventory in the bars, then it's gonna come up for you. But in trains, something better happens, which is it shows you these arrows. Anywhere you go, anywhere you have already something of a track laid down, you can see the arrows. The arrows are there to let you know that you can continue off here with the builder. That's the builder. Having the track on your cursor and then placing it over another track brings up the builder. If I press down with the left mouse button now, I can start moving and building. Anywhere that's legal to go, it will go. So here it says I cannot go there, but I can go here. I cannot go here, I can go here, and a specific distance away. I can even turn it for a bit, create turns like that, but that's it. I cannot move it very far away. So press the left mouse button and you will continue to build it. Press the right mouse and continue like that, and everything is great. Forgot about that. Okay. There's another way. Again, you don't have to press Q. If you press Q, it's just going to bring up. If you select it and move it over, you still get the builder. Pressing Shift and then left clicking will bring up the planner, basically. This is infinite range. Of course, if I place it here, in a normal game, it will just place the things that are near me, the ghost for it. Sorry. But this is a cheat mode, creative mode, so that I could build everything that I wanted without having to research everything. So this is why this is not like that. I do it like that, then it's placed. But watch that it basically is an insane distance. Shift click and then you can move it anywhere you want. Some thoughts on how to control this. If I bring it here, I may say, oh, well, I want to bring it here, but I don't want it to face like that. So you press R. By pressing R, you shift and you maintain one single orientation. You go away and you bring it back up. You see that the orientation here, while first time in the planner, changes. Now it is looking from from the center of the screen to the edge, and now it's going to look up and down, and now it's going to look horizontally, and now it's going to look diagonally again. So it's changing based on where you using it. If you press R though, it's going to lock it in one position. Keep pressing R and it's going to change it. And that way you can bring it where you want. Even here. That close. And now there. Now this is a circle. So you've made yourself a circle. And this is a circle that you can use and it's fine. That's the planner. So what good is this? Well, placing down trains. There it is, there's a train. So it will lock obviously to the track, but it doesn't lock orientation. Now this is very specific orientation, but press R and that will change again. This now will go from that direction and this goes that direction. Placing it down has this icon because this is like a gas pump that tells you there is no gas inside it. Click it, left click, and you bring up the interface of the locomotive. The scheduler is here with automatic and manual, meaning in automatic it will run the program. In manual you can just jump in by pressing enter while close to it and moving it, but it doesn't have any fuel, so we cannot move it anymore. Fuel is where you have the fuel, obviously. You bring it into here and now it's fueled. See, no more icon. I can go inside it now and it goes forward and it goes backwards. Simple enough, isn't it? Well, what good is it? Well, let's equip that one a bit and see. The stations. We can have stations, and when you select a station, then it comes up like that and you can plop it down somewhere. So I plop it here. So what's this called? This is called train stop 1. So that's 1. I've named this 1. Great. So if I go into the train and add a station, I would go to 1. And do what there? Just wait. Don't have to do anything, just wait. And then click on automatic. Well, that doesn't go anywhere. No path. And no path is there because it doesn't have a path to it. But you might say, wait a minute, but you can just move forward and go. No. Stations have a specific direction, and if you move over it, it tells you. It also does the same thing if you're placing it. When you're placing it, you can see the direction arrows. The green squares are for where you can place it, so it's very specific. You cannot place it anywhere you want. And the arrows on the tracks is the directionality of the station. In this station right now, as it's placed here, it can only move from right to left. And since the train cannot go to the left, to the right of the station to come in like that, then it doesn't have a path to it. It's plain as that. So let's scrap that by pressing the remove the station which I was under and do this, because now this station does have directionality which this should go to, right? So we open it, we fuel it, we select 1, time passed, and then manual. And there it is, it went. Lovely. So what happens if I want to go to multiple stations? Well, here's multiple stations, train 1 and train 2. So let's equip this then with train 1, time passed, and let's edit that to 1 second passed. And then add another one, 2, time passed, and again 1. Add fuel to it, so now it stops being saying it doesn't have any fuel, and click on automatic. It goes to 1, it waits the 1 second, it goes to 2, it waits the 1 second, and now it doesn't have any path again, because how can it go back to 1? This shows us that the schedule is cyclic. It will do one, it will do the other, and then go back again to do the next thing. Since it is in 2 and wants to go to 1, but there is no path for it to go to it, then this is why we have no path here. Let's see what happens when we have one station, but it can go round and round, can it? Sure. It's that. What is the name of that? That's 1. So let's give it 1. Time passed. 1 second. There you go. Good. Move. Move? No, it's not moving. Because it needs a second command. It is in 1. It doesn't make any sense for it to go again to 1. It is already in 1. It needs something else if you want to create something. Which is exactly why this doesn't say no path while this does. You see, this is sitting there. It doesn't have anything else. It just has the 1 and sitting there happily, even if I change that, which I didn't, for example. But there. Now it has 1. And it's keep sitting there, doing nothing. It doesn't complain. This does, because this wants to go back to the 1. This doesn't want to go back to 1. It's already at 1. So let's add another one. There. You are now 2. And if I add a station 2, time passed, 1, now it goes. And it will keep going up and up and up all the time without stopping. This is now a cyclical program. It goes to this, it goes to this, and both of them have some proper, like, path from one to the other. So that's why this is working. So there's another thing you can do. You can create a two-headed train. Because this is, for example, if I had a two-headed train here, then maybe it would go here. Well, we'll see. So we have this station, we have that station. Let's make a double-headed train because that can go both ways, so that will solve our problems, right? Well, possibly. So let's feed this, let's feed that, and now this is called 1, this is called 2. So again, go to 1, go to 2. 1, time passed, 1, go to 2, time passed, 1, go. So it goes to 1, and then nothing, no path. But why? You have both ways, you can go both ways. You could just go forward and then come back and then hit here, because yeah, this is that directionality. So it's theoretically possible that this could advance. So if I stop it basically, and I go in and I go manual, it could say go here and then, no, sorry, come here and okay, there, I'm docked. No, that doesn't work like that. It needs to go straight. It's not gonna go somewhere, stop, and then go to it. This cannot work because it cannot go from 1 to 2 within one motion. It will not stop and reverse course to make it. This is why this will work. This configuration will work. Obviously, this train cannot go to 2 for the same exact reasons. Let's select this. Go to 2 and go to 2. Both of them need to be fueled, by the way, in case you're wondering. That's why we need to fuel both of them. Why I do fuel both of them. So let's go to 2. 1, go. No, it will not go. Okay, it will not go. Fine. Then let's go to 1. Still doesn't go. Why? Well, that's because of the programming. The programming matters, obviously. It tries to go to 2 right now. It cannot go to 2, so it will not go to 1. It will not ignore it. It doesn't ignore stations in case it cannot make them. It will only ignore stations when they're turned off, but that's far into the future for maybe another lesson on circuits, which I doubt I'm gonna make. But yeah, you can turn stations off. Stations like that, which are vanilla stations and plain stations connected to nothing, they are always on. And if they are unreachable, then your train will not disregard its programming. Right now, it's trying to go to 2 and it cannot. So this is the third button now, go to stations. I can't force it, while in automatic, to go to another station. And now, since it has a program that is feasible, because it can go between the two, the program is executed. And will continue to be executed for all eternity. So what happens now when we want to cross through stations? Well, here we have another train, which is very happy, sitting there waiting for me. And this name I don't like, so let's change it. You click on the rename, you type something 1 down, which I already don't have, and then apply change. Now this is 1 down. Now let's go to the other one here. This is also a name I do not like, 1 up. And there you go. Now it's changed. So let's take it and send it there. I mean, they will see each other, right? They're not stupid. Let's go to 1 up, time passed, 1 down, time passed, and 301, 1. Great. Go. Yay, they managed it. So, cool. Trains are intelligent. Awesome. No problem whatsoever. We are set like that. We don't... Oopsie daisies. No, they hit each other. What the hell happened? Why would they hit each other? Don't they see each other? No. The trains do not see each other. If you leave it like that, then things will break. And this is low speeds. These things will happen all the time. If it's moving at any bigger speed than that, then they will plow right into each other and destroy them. let's stop this, because they will continue to bash each other's heads in until the cows come home. So what do we do? Well, that's where chain signals come in. This is a simple intersection, and this whole screen now lit up. Don't worry about that. Sorry. So, signals, not chain signals, sorry, normal signals. Rail signals. What do they do? Well, right now, when you have one, this thing happens to your interface. Like stations, the boxes tell you where you can place a signal. This is red as a signal, this is green as a signal. See? Red, green, so you can place it there. It also gives you a directionality, which is going to be important later. Now, when you also have it moused over, you see a line. You see that yellow line here? You see that yellow line? Now that's gone. You pick up a signal and it's there. You pick up a train, it's not there. You pick up a signal, it's there. Because that yellow line is only relevant to the signals. That's going to tell your trains where to go and where not to go by using that line. So the theory is, and the practice of it is, that we break up the paths into blocks. They are actually called blocks, and that's actually from real life as well. That's how real life trains work, by blocks. We are going to split them up and have it work only by letting it know which block is available and which block it isn't available. So this is we have directionality, as we said, so we're going to place it in all ways. We're going to explain that a little bit later. Or shall we explain this now? Shall we explain this now? Yes, we shall. Okay. We're going to need to break this up so that this intersection can be always kept clear. I've placed something here, then that gets cleared. That's fine. But now we have two blocks, one the red and one the yellow. Now the yellow is all, again, it's not split down the middle. We want to separate this into something that can be denoted as one block on its own. So we need to also block this part, and we need to block this part, and we need to block that part. So there, now it's fine. Everything is working. Where is it? Let's re-engage. Well, nope, it's not working. First of all, this is on this signal. You see this? The train is on this block. So that's why this now is red. It doesn't let it go through, although it wants to. Because this does want to go. It doesn't have a no path as this does. This does want to go, but it's because that train is on that block, it doesn't let it. If I take it for a spin and just say move, now it's open. Now it could go. Again, that cannot go now, because why? Because of the signals. You watch the directionality. You see this? This is showing that this track can only go that way by the arrows. The arrows show the directionality of the rail, and there is nothing else to oversee this. Before, it was happy to go up and down on its own because it didn't have any signals to enforce the directionality of the rail. Now it cannot, because the signals are enforcing it, even though the station says down, but this station says up. The station does say up, but these signals only say down. In fact, it just takes one of them to enforce it. There is nothing else to do. Signals will always override the directionality of the rail over the stations. The stations do not affect the rail. The stations show where do you need to approach me from to reach me. That's not enforcing any directionality on the rail, but the signals are. So we have them like that. What we need then is to add another directionality. There you go. Now the train can go up and down. What's that? Why doesn't it go? Well, why would it go? See here, this block. What's this train on? This train is on this block. It still doesn't allow it to go forward because this train is on that block. That's the whole point. The whole point is for trains not to go to other blocks that have other trains in, and you are meant to design how those blocks will operate. So since this is also blocked, now it's broken, Doesn't matter that we've broken directionality on that rail. All it matters that now that we have freed this by placing it there. By placing it there, we've cut it across this line as a block, and now this is available. Nothing, no train is on this yellow block now. This entire yellow block, no train is on it, so that's allowed to go up and down because those signals are gonna be green when it comes to it. It comes up, it's green, now it's yellow, meaning okay, something is coming and it will not stop at this point. And then it's red when it is inside, and once it's out it becomes green again for the next train. This train, in order to move, it will not move because again, directionality. Also, not only directionality, but it's also not able to go because we said it's blocking it. So I'm putting it here. Awesome. Sorry. There. Now it's going. And now it's gonna go. And now it's not gonna go again because directionality. We add this path then, and now that is completely fine intersection. Well, completely fine, but it could be better. So let's copy that. Shift right click, shift left click, and now it's copied, and that's fine. And now it will move a little bit better and clear the path for that to go up and down. And now that's working. Same thing to this. I actually used that model above, so I don't have anything more to explain to that. So moving on. We are going to show real trains. We don't have any real trains. Let's design stations then. First, directionality, right? This goes there. We have that, and we have that going that way. Now this can go both ways, and that's fine and dandy. Good. The other train we're going to design a little bit differently, because why not? There. And there. Are you saying this is stupid? Yes, I know, but that doesn't matter. There is this to go take it that way, and there's this to take it that way. This will work. So shall we make it work? Yes. Shall we place signals? Yes, let's. Where? Well, what do we need to isolate? Do we need to isolate this intersection? Do we need to isolate something else? Well, let's see how that goes for now. Well, that's working, but they don't have any plans. This is one, this is unload, so let's build it. Go to 1, inventory item count, let's go with plastics and 100. And then go to unload, inventory not full. I want inventory empty. And go. No path. What happened? Well, it's with 1, isn't it? Load 1. Let's load 1 at 1. Where's load 1? Load 1. Item count. Click that 100. So now it's taking up and it's gonna empty itself out. So that was a quick fire round of how to build an actually useful schedule. So let's examine it a little bit better on this side. Click on the train. Add it where you want it to go. Well, I want it to go to load 2 because that is load 2, right? I want to go to load 2. What do I want to do there? Well, one way would be I want to have inventory full. That's perfectly fine. But right now I just wanted to move quickly, so I want to basically tell it to have a specific item count. So I wanted to specify an item count, and that says cargo something 0 because that's all there is now. So I click on this button and I bring up all the things that Factorio can have. And since I'm moving plastics here, I'm telling it it's plastics I'm interested about. and I want you to have plastics 100. Now I'm saying over, and I'm not saying equals, because equals is meaningless. Equals can go away very, very fast and not be caught by the system by virtue of the inserters having bonuses. Your inserters over here, especially stack inserters that we are going to use for the most part in stations, are transferring more than one item at a time. And since there are 6 of them, they transfer at least 6 items at a time. So if you have this equals to 100, you may have 14, 6, 6, 6, 6, or how many more, and then reach 96, for example. And the next game iteration will see the cargo load with 102, and then plastics is going to be 102, and it's not going to be 100. So it's still not going to be satisfied as a condition for waiting. So that's why we say as long as you have more than 100, any number, just go. What else? We need something else to do. As we said, we need 2 stations to do something. Otherwise, it's just going to come here and then sit, because it doesn't have anything else to do. In fact, there. So what? Nothing happens now. Who cares? Now we want to do something else. We want to go to unload, and we want to say inventory empty. Just empty it out completely. That's fine. And now this doesn't go, because of course it doesn't, because it needs to be reversed. No, it doesn't want to go. Why? Let's see. No path. What is it? Unload. Load to. It cannot go to unload. That's interesting. I cannot go to unload. Oops. What's that? There is something here. There it goes. There is something here ordering directionality, which means I cannot actually use it. If I remove it, then that will happily go. And there you go, they're stuck. As we knew they would. So let's break it up for them to actually be able to do something. So, directionality, we need to take care, so let's break it like that. That's broken up. That's a good break, isn't it? Sure. Go. So, that's gonna wait until that is empty, but is that ever going to be empty? No, because that's always gonna be on the yellow part. What's that doing? It's just emptying incredibly fast. That's fine. That's less than 100. Stupid. More than 100. There you go. So, this is not helpful, because it's just going back and forth and not doing anything else. Well, what if I break it like that? There you go. Now what? Okay, now they can go. This is all that you need. This right now is all you need to achieve this design. Of course, that also means that this is irrelevant, because we don't have it anymore, so all we could have really said is do that. And we don't care about that. Don't care about that. This will go away. But now this doesn't go away. Wait a minute, what just happened? Isn't it the same? Well, again, take out the signal. What do we have here? We have a yellow block here that goes there, and then a red block here. But this red block here, right here, this red block is continuing all the way to this red block. The other configuration broke it completely between 3 of them. One block here, 1 block here, and 1 block here. And that's why this works. As long as we put something like that, it's going to be fine. Cool, great. Well, that may be fine for 2-headed trains, but what about 1-headed trains? Well, let's do this. This is one-headed trains. This already doesn't have any program, so again, load one, go to unload. So like that. Right click on, shift right click on the engine, shift left click on the engine. There it is. Come on. Shift right click on the engine. Don't get stuck on the trees. Shift left click on the engine. There it is again. So now they have schedules, they have everything they need, and they can start working. This is just one-way trains, and they are going to come here and then come back, and this is going to come here and come back. And if they actually worked, instead of just sitting in manual, that'd be great. Boom. But we knew this already, didn't we? Yeah. Just trying to reinforce the feeling of remember signals. So, what kind of signaling do we want? Well, boom. First of all, how about we just denote this guy? Now we only need one signal, by the way, because this is a one-headed train, so that only needs to go one way. So what if we break this? Do we know if we can break it here, though? Well, yes we do, because you'll notice that we also have these other things that are brackets. Brackets show you where your engine and cartons are gonna be. Carts are gonna be, not cartons, carts. So you have the first white thing, which is gonna be the engine, the second, which is gonna be the cart, and then nothing, because we only have two entities in our trains. So this is the end of the, basically this is the end of the cart. So we can actually place here, and there we go, and that's not moving because this is blinking. Why is this blinking? Because we need to separate it into blocks, as we have said. It cannot be just like that. So let's just block the station. You can go. You can go. And now it's orderly. The point is that enough? Will that be enough? Don't I need to safeguard from anything else? Well, let's wait a bit, because these have massive things. This doesn't go anywhere. Why doesn't it go anywhere? Not load 2. Hold go. What happened? It doesn't let it go. That's what happened. See, this is red? So it's not enough, is it? Because this is the beginning of the yellow block. The yellow block goes all the way up here and then comes back and then is occupied by this train. So this train behind it is occupied. So might as well just block it like that. There, it left. Is that going to be enough? Probably. This is probably going to be enough. For a two-weapon system, for a two-train system, that is going to be enough. But what if I want more of them? What if I want to add here and there, and then just copy this to that, and then go, and also take some fuel. Oh. Okay, so it's gonna wait there, and then what? No, again, do I have to actually mark all of these in and outs? Well, no, actually, I don't. What I do want is to block these. And of course, this. Now I have some more blocks to work with. Of course, again, this is not gonna be enough if I want to bring another one here. This whole thing is one block. All of this is one block. So no other train can ever go inside this when this is there. And I can see this. Shift right click. Bring something in here. has to cross there before that can go even there. It's all about how many blocks do you want to separate. You need more blocks to separate than that, or this will soon run out. We have a lot of track to consider. Block it like that, block it like that. Again, now we have more to work with. Go in, that can go further in. While that is inside, see, this works. This is a good system. Again, for the beginning. How about we have something a little bit more, a little bit bigger? This is the continuation of that. We have a big cross section here with things that I want to go certain ways. That was a simple thing. This section here was just basically a simple thing that you don't even have much sense in doing, because yeah, that's way to close distances and we would usually do this by belts. But this is something a little bit more typical. You will find trains cross sectioning like that. And when you have trains cross sectioning like that, then you're gonna have problems. Because what we did so far was just basically define this. So now we have trains waiting and waiting and waiting, because this is blocking. Why is this blocking it? Because it has this there. Why has this there? Because reasons. There. Move off. And now that blocked it again. See, we cannot just have the intersection blocked off like we have them here. This is one intersection and we have it blocked off, but this is not exactly... This may be one intersection, but it's actually 4 intersections. And that's why we need to block them in this fashion. Again, this is prone to blockage though, because look what happened there. That moved, okay, that moved, but they were actually blocked for a bit, and then this was gonna block because it moved. It doesn't allow that to come down, and then this has to go before this can proceed. And why did you come inside? Something else could come in, and oh my god, yeah, why did you get in? This was coming. All this confusing. Why did you go there? You're blocking my way. They will not crash. They will not crash, but they actually could, given sufficient weight to them. Add something. Let's add that. See, now they're blocked already. Again, they're blocked. Just because I added a little bit of bigger train, because you also need to consider the block size. This block size here, from this station to that, is not long enough to fit this. And that's why this didn't, no, actually this didn't go to manual, sorry. Let's try that again, but now they're not manual. So what happens? Yeah, they go, they progress, they move, but they could get blocked really soon if it's doing that. Yeah, are you blocking? Well, you are kind of blocking, you're not letting that go. And where are you going, and what's this going? And yeah, again, these try to... It's not efficient. So that's why we have the chain signals anyway. That's where I was going to. That's why we have the chain signals. The chain signals are what's going to prevent things from blocking each other, because the chain signals work in a different way than the normal signals. Then this signal is just cares about the one ahead of it. It has the directionality, so it says I'm going to go that way, so I'm considering the next one. See the arrows? It's going to consider the next block. Is the next the lightly blue one free? Well, yes it is. But we saw that it turned red before it was actually full. That's also part of it. If another signal, specifically this one, indicates green and yellow, then it blocks it. It blocks the next signal, and it's going to be yellow when a train is coming in a sufficient speed that will indicate that I don't have time to brake in time to avoid going into the intersection or into that block. So as soon as the train is too fast to brake, that will turn green. Turning that green means it's blocking this intersection, which means that this then turns red and doesn't let anybody else come in. So that's why this turns red before a train is inside this block. That's all it does. It's considering the next block, and that's why these are allowed to go inside here. This is allowed to go inside here because, yeah, only this was red. This was green. So it's fine. Go, yeah, like that. I don't care. You can go in there. But this, in the meantime, has been waiting for so long to go there. Chain signals allow considerations of exit. Now you have no blockage inside the blocks. This was allowed before this ever came, so that's different. But see, this is not going there now. It allowed this to go up, to go through, even though it has some time to go. But you see now there is no blocking. This could actually go if it wanted to, but I guess this is a little bit too far because it's now 4 and it's not 3. Yeah. So let's see it without this. And automatic. It's waiting because that was blocking it, so that allowed the other one to go like this. This allows it to go like that. They're waiting. They're gonna wait at the end. The point is that they will not come in. The chains say, this is a chain. Awesome. Is my next one after the normal chain free? Where is the next one? So going down, this is the block. This is not a normal one. This is a normal one. So is this green? If this is green, then so am I. If this is red, I am red. If this is green, I am green. It's based on the last normal signal to the chain. So you are creating an area of freedom. You are creating what the developers like to create, to call an exit guaranteed path. Because basically this is saying you will only be allowed to cross this signal if you can go here after the normal signal. So if you can go here, that means you are going to clear this intersection completely. So you are allowed then to go. This is very useful for cross sections, because cross sections guarantee a completely blockless pathway by provisioning that the exit is guaranteed. So let's see about developing it. How do you develop? Well, one of the best things I have found is where will it come in? It was like this before. So this is what it's working, but it may actually also break. Giving sufficient trains, it will break. Giving sufficient length, it will break. The way to think about placing the chain signals again and creating the guaranteed exits is by following the paths of the train. Obviously, it's much simpler to do with single direction trains, which is why we're doing it here. This train goes from right to left, so the entrance to this intersection is from here, where the entrance gets a chain signal. Then everything else that doesn't clear an intersection gets also a rail signal, because we need this to be a marked intersection as a block. So that also goes here then. And now we have our block marked. And we also have a path of guaranteed resistance exit here by having these two chains and going like that. So since this is a symmetrical view, then it becomes easy. This is from top to bottom, so again 2, and that guarantees it. From left to right, there we go, and from down to up, there we go. But it's gonna be a little bit more interesting to do when we discuss things like that, which we are possibly gonna do in a while. Let's see. This is blocked because this doesn't have any fuel. Okay. This is not different than what we had up there. This is basically a real-world example of what I would have used here. I don't use these squares in my designs, I use these. So these are actually going to be far more useful because they allow directional change. This can go from here to there, or to here, or to up there by going wherever you need to go. So these are very nice to have spread around your network so that the trains can decide for themselves where it's faster to go. So let's see if this is going to survive with the long trains that we want to design. 4 trains, 4 carts, which is standard. 1 and 4 is very standard. Let's add another one. Oh. That connect them, sorry. Okay, go. And for the last one, there you go. Go. So what's going on? There. It already broke. It already broke even though we did exactly as we did up there. We have chain signals defining the intersections. Remember, this is just the same thing as before. Nothing has changed. All it has added is directionality, and they're not even changing directions. This is the same system as it was before, only now, while these can work with just the normal signals as we've seen, this doesn't work anymore. You have here 1, 2, 3, 4 sections inside where the tracks meet. You have the same things here. 1, 2, 3, 4. Nothing has changed. But now, because it's actually a little bit of a real-world example, this has blocked. We have blocked it here, we have blocked it here. This is exactly the same thing as before. So that's where we actually see the need for chain signals. Now let's add them. Entrance, and then the second part to denote the signal, right? Entrance, and the second part to denote the signal. Entrance, and the second part denotes the block, sorry, signal again, block, entrance, and the second. So now this will work if we just make it a little bit, clean it up a bit. There you go. And I'll take you and move you down. And move again. So now that's unblockable, and we still have concurrent traffic. And we haven't even done anything massive. They're waiting, they are allowing traffic to go on uninterrupted. This is why you need chain signals. It's a thing of beauty to behold. So let's just go over how to build it in a little bit different way. You have this. This is something you've built. Maybe it's not a roundabout. Roundabout is easy. There you go. Build it, copy it, it's gonna be fine. But let's actually drill down on how to make the signals work. So let's say we want this top line to be going up, and we want these 3 to go up, and these 3 to go down. Right? Right. So this is going to go up. Fine. Let's start by going like this. Well, okay. We don't want that. This is going to come here. This is now going to come here. We want this then to clear and to be denoting of blocks. We need directionality that way, so that's gonna come here. We always start with a chain signal at the end of the intersection. So there, that's the first one. This intersection then needs to clear, right? This needs to be defined. So we're going to be defined like that. What's one way it can go? Let's travel it. Da 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 da. It comes here. There's another intersection. So before that, there's something else. There we go. So then that becomes all the way up here. So there's another intersection here. There it is, another block. Awesome. And then that's gonna exit. And is there anything else after that? No. So that's a normal chain, normal signal. There it is. Fine. What else can happen? Well, it can go up that way. And if it goes up that way, is there anything else to go? Any other intersections? Nope. Let's block it off as well. There we go. And that, is that going to be, it's going to go up, but there is no other intersection after that, so also place that there and we're fine. What else needs to happen? Where this is going to go, we can go that way, the train. So this also needs to be blocked. And then if I go that way, this needs to be blocked, and then this needs to be blocked, and then this needs to be blocked because there's another intersection here that we need to close and it's not exited yet. So we take that because that's the exit. There it is, blocked. Now this will come down. You know, this is down. If it's coming down, then it's gonna come into an intersection. There it is, blocked. And there is the first good defined block that we have. We need to build up the rest of them. What about here? Do we have any other exit to attempt? No, we do not. So we take that. There it is. Is this going to be then where else? Yeah. That's defined. That's defined. But this is not defined. There we go. There. Now that's cut. And this is another block that is defined, and this has stopped blinking. This has not stopped blinking because all of this is connected yet, and it's going to stop blinking when we actually make it. This last line actually connects to nothing, so it doesn't need to our consideration at this time at all for defining what we want to do with it. But let's go from here up. It's going to come down to live that way. From here it starts then there, and it's gonna block here and block here, and that's gonna block there because that's the entrance. That's the entrance. This needs to clear that intersection as well, and that's why we place it there after this. This also needs to be cleared, but that's not the exit of it, so there we go. Then that's confined here with that being free, but not exactly because it needs to exit here, so it needs all of those to be free before it moves to that side. Then we need to block that, and we need to block that, and now we are exiting, so there we go. However, this can also come from up, so there, and block this, and this can come also from here, and we block this, and we block that. This also can come from up here, so we block this, and we block that. And I think this has been all defined now. So let's see. We are coming from here. We hit the first intersection. We see a green chain light. That means we are guaranteed to exit. Is it so? Yes, because there is nothing here, there is nothing here, and there is nothing in this block upstairs. So I can exit. I come from here and I go up. Yes, this is one section, this is another section, this is another section, this is not another section. There we go. And now I can exit because I have this free. Awesome. I come up here, I come here, there, I need to stop there. That could also work like this, for example. We can also define it like that, and then like that. And this is now one defined intersection on its own. Although that does cross into here. Yeah, That's the problem with the intersection though. Yeah, that intersection is a little bit poor. It needs... there. There, and there. Yep. As long as we have, yeah, there, and there, and there. We needed 3 of them, we found the 3 of them, now they are all defined. Now they are defined. Why? Well, this needs to decide where it's going to go, but if we place it here, then this associated with this line, which is what we want, and that's why this works now. And then, of course, this is going to work with this. Oh, cool. Do we have an exit? This is not an exit. This is the entrance. And what if we want to come from here and go all the way down? We have this intersection as blocked. We have this intersection as blocked. We have this intersection blocked, this blocked, this blocked, this blocked, which means I am creating blocks, not actually it has a blockage, but it has a block, a well-defined blocks, 1 per intersection. So all of these are defined well as blocks on their own, so this intersection is now ready to receive traffic. And this is how to do it. This is how you create the train structures you want. So, I hope you found this useful. If there are any questions, please let me know in the comments, and I'll try to answer them as best as I can, even by clarifying parts of the video, and maybe creating a new one. Depends on how well you found this explains things or not. Thank you very much for listening. Do take care and keep safe.